Hello, everyone, and welcome to the November 2022 Integration Down Under. Sorry for the miscue last week, but we've got Mick this week, and we're going to get on with it shortly. Just a quick couple of slides from me. The organizers for Integration Down Under, Martin, Dan, Mick, and Wagner, and myself here in Melbourne. We're two of those five now are Microsoft, Martin and Wagner. So, but the rest of us are still not Microsoft and still MVPs. So let's go ahead and go to next. And this is a little bit about Mick's talk, but we won't spend a lot on that. And that'll be just in the recording if you want to have a look at that. And let's go. And let's hand over to Mick. I will add your stream to there.
Beautiful.
And we'll hand over to you. And I will get rid of our pictures and just go full screen on the slides.
On that one? Okay,
yep.
Beautiful. Thanks, Bill. Must be something to do with this group that, we sort of migrate to Microsoft at some point or other.
I'm too old for that.
You're a spring chicken. All right. So, welcome, folks, on the last day of November 2022. And we're all looking forward to the end of year, no doubt. What I thought I'd do is just talk a little bit about creating efficient webhooks or callbacks, as they might be called elsewhere. Because just in my recent travels and, recent work over the last 6 months or so, they've really played a vital role. And I just want to walk you through some of the considerations and some of the thoughts around how we do this. And I'll talk to you about it and have some great discussion points as well. So here we go. So in terms of the agenda, well, we're going to expose out an endpoint, and it's a callable endpoint, and surely, that's all that we need to do. And once we've done that, click next, publish, we're there, and so be it. But it's not really it. And, I want to talk through why it isn't really it. And a lot of solutions that I see is, as developers around the room and things, we've all got certificates above our cubicles and above our workstations that say works on my machine. So every time something doesn't work, we point to it and say it works on my machine. And unfortunately, enterprise integration doesn't exist on a developer's machine. A lot more happens out in the wild that you need to be considerate of. Hopefully I want to bring a few of those points to life tonight or for this talk, wherever you may be. So strap yourself in and get ready. All right. So, how do we start off? And with everything, we start off simple. What is the simplest version of what you're looking to build? And get that going, get that deployed. Test it, see what's happening. And, if you think about it, it's like a wireframe of what you'd like to do, an end-to-end wireframe, or how can you get enough in place, enough infrastructure and scaffolding in place to really just test out the basics of what you're doing. So very similar to, animation movies and things like that, where concepts and ideas, they all start with wireframes and sort of go, yeah, we like that. We think that's going to work. That one, not so much. And then they go and apply the full color and everything else to it. So it's a little bit the same with what we're doing here. So let's expose an endpoint and then let's see what we can do from there and observe what we've done. Because often when we're exposing endpoints, the challenges aren't so much in the code itself. Is it callable? Can I get to it? What's the security look like on it? When is it called? Is it called in the middle of the day? Is it called in the middle of the night? Or we don't really have any set patterns. So there's all these other things outside of the technical arena, I suppose, that we need to be considerate of. And so if we can get our vanilla endpoint You might have heard the phrase mock up an interface or an endpoint. Then we start to do that. What is the simplest version of what we need? So in terms of, I've only got a few slides, by the way. In terms of exposing an endpoint, there's a few other considerations that we need to make. And some of those considerations, I've just written those down out of years and years of doing this, of experience, is, well, when we expose an endpoint, it starts to become quite a vital and quite an essential piece of our solution landscape. It's there. It's now callable, whether it's callable to other components in the solution, let's say internally, or whether it's callable to our partners and B2B. And typically in an integration sense, we're extending the reach of our solution and having that callable. What I want to sort of frame this as tonight, or in this discussion, is we're exposing not just an endpoint, we're exposing a webhook or a callback. So we've got a SaaS service out there, and typically, payment gateways are very good candidates of this, that something will go on their side, on their platform. Maybe transactions go through, maybe you've got a customer base that are using cards or using some sort of, payment or on-platform type financial services, and the payment gateway provides a callbacks. Will call you back to let you know the status of various transactions that have occurred through the day, or day and night. So rather than, if you think about it, it's a way to scale as well, so that rather than every time someone performs the transaction right there and then, a callback is made into our system from the payment gateway provider saying, this just occurred, please process it. An amount was moved between accounts, or whatever that might be. What they tend to do is batch them up and queue them up. And essentially, when their system is ready for it, they will queue up maybe 40,000 callbacks or 100,000 callbacks and just send them through at depending on the payment gateway and where they're located in the world, will determine what your busy hours are or when that traffic is going to hit. And typically, in the experience I've had, it's usually between 12 during the day to 2, around there for a few of these. So what do we do? And, we've got our endpoint that's been exposed. And, what does support look like for that endpoint? And how do we upgrade it? Because, typically we can't be taking these things offline, at a whim, and then say, oh, we're doing some upgrades. It'll be offline for 2 to 3 hours, whatever that looks like. And then it'll come back up, and, fingers crossed, that's the happy path. And, what happens in the unhappy path? And then, a question that we don't really ask on a developer's machine, and that is, well, what does performance look like? And that's it's always a tricky one to nail down, because it changes. It changes based on, what your callback is doing. And so how do we ensure performance, and how do we, go back to the business with solid numbers and be able to talk about that performance? So the next point there is, well, what does our callback do? So when the payment gateway calls us, what does it actually do? So it's got, these transactions. They might come through individually. They might come through in batches. It really just depends on the type of interface and conversation we're having. But what does it do? Does it, take take the message, the request over, off the wire, parse it, for example, have a look at it, maybe validate it, maybe save it to a database, for example, to persist it. Maybe there's some updating within our system that needs to happen as well, so that the actual accounts and their amounts are reflected on our side as well, on our solution, and not just in the payment gateway providers. And the second part there is, well, what can it do is a really interesting question. And we'll talk about that in a tick, because as you're probably getting the sense of, we've got a callback and we're coding it up. And so once we're coding it up, it does a whole variety of different things. And that's the part of, well, what does it do? Now, do we ask the question, and have we asked the question at all? What can it do? And out of all the things that it is doing, should it be doing them? And I'll give you a bit of an idea on that one shortly. So other things like, what about reliability? It's an essential infrastructure piece. It's a callback. How do we ensure reliability? And that's, largely by how we host it, but also by, some of the considerations that we make in terms of what it actually does. And then, what does scale look like? So, what does scale look like? We've got an endpoint that can be called back by, a variety of different SaaS providers. And in our example, it's a payment gateway. So I mentioned numbers around 40,000 requests. And, is that enough? Is that too much? Is 1,000 concurrent requests too much? What happens if we have 20,000 and we have some of these big numbers? Do we go back to our payment gateway provider and say, by the way, we can't handle that volume. Can you please send us one a minute or one a second or whatever? That's a really difficult piece of functionality to implement. Not saying it's impossible, but is there something that we can do that's better, that we can indeed handle that amount? And then, obviously when we've got a callback or exposing an endpoint, what about the unhappy path, exceptions? How do we know that? And how do we get visibility into those? So these are just some of the things I thought I would, just raise questions around to jolt your mind in terms of, as we're building these out, these are some of the things that we might want to consider. And then the last little point there, in the era of the cloud, and we can post things up on Azure quite easily and wrap them and have other things in front of them, such as API management, various API gateways, front door, various other things and services. What is running our endpoint? So maybe we package it up in a container and it's running as part of a container service that's there, or maybe it's running part of Kubernetes, or maybe it's on a plain old Windows instance or Linux instance app service. And is there a difference between those? So in terms of how it actually runs, is there a difference between if I deploy this on a Windows instance versus a Linux instance? And certainly, in the world of .NET and similar languages, we compile and we run everywhere, right? So .NET 6, with the advent of .NET 6 and Core and things, it all merged into one, and we've got sort of now the capability to run on Macs, to run on variety Linux, as is very simply, very easily. So we get all this convenience, but is there actually a difference when we're building things like our endpoints and callbacks? And do we need to be mindful of that difference if there is? So as I mentioned before, when we start to talk about enterprise integration and those sorts of things, it doesn't exist on a developer's machine. right? So these are all things that we can run tests on, and we can run it on our own machines and go, yep, this is fantastic, working really well. I've got 100 concurrent requests going through, no problems. And then we go and deploy to a different environment, whether it's staging, test, UAT, production. And, sometimes they're vastly different. So, for example, in Azure, we have a dev test subscription that we can use. And so dev test subscriptions allow us for exactly that typically it's cheaper pricing on all the services that we use. And it's there with the proviso that, yes, this is for development and testing. We don't expect it to be up 99.59s availability. We can handle some interruptions if need be, but it's generally a lesser grade, or potentially we can have disruptions on it. So that's fine in dev test. Then we go into prod, and prod is obviously it's got to stay up. It's business critical and mission critical, and we can see some different, or I certainly see some different topologies and different deployment topologies, such as running things on Linux instances, and what we and for maybe cost effectiveness, or for a variety of different reasons, production might be slightly different, because it's in the tooling and in the deployment pipelines, it all looks very, very similar. We're just choosing a different instance type. One might be Windows, the other might be Linux, and please go and deploy onto that and run it. Now, what's the impact? Well, the impact can be that if we're running it in a Linux instance, it actually runs the container behind behind a Windows box. So the calls go into IIS originally and then get farmed or routed to your container, which is running Linux, which is then running your application or your APIs. And so what web server or HTTP server is running in Linux to service and serve back those requests. So there's an extra couple of little hops that get introduced behind the scenes and under the covers. And maybe if it's a quiet endpoint, you don't see it. The only time you start to see and notice these things is when it starts to get busy, and maybe capacity or scale comes into question, particularly if dev test is slightly different. These things have a big impact. So that was a long slide. Look, some interesting thoughts just around the notion of we've decided that we'd like to expose an endpoint. So once we expose the endpoint, that's it really, isn't it? And we're done. So some of the things that we're considering here is that we'd like to code one up, and I'll show you that in a moment. We'll take an incoming request, we might parse it, we might do some things with it, and I just want to walk you through a journey on that. So let me go to my code, and I'll bring that over. We should be able to see that. Wouldn't be a great demo, wouldn't be a great talk without a picture of Visual Studio every now and then. So this is just quite a simple little piece of the puzzle, and it doesn't do a lot. I've got a couple of little interesting things in here which I'll talk to you about shortly, and these are just metering, if you like, or instrumenting just some of our code. And I've got a sample project here which I haven't done pretty much not much with. I've written some code in here, and that's it. It's pretty vanilla from a, file new, give me an API project, web API, there you go. And my program.cs is looks pretty similar. The only thing I did was just to get some Swagger endpoints when I deploy this. So nothing, all pretty much the same. Now, the first scenario, so this is going to be our webhook, and we've decided that we'd like to write some code to do this. And so this is just very, very vanilla. Okay, so I've got an operation, and somewhere or other behind the scenes, when a call comes into wherever this is hosted, the plumbing knows to run my code here. And my code comes along, I'm just simulating some work. So I say sleep for 1,000. I then update one of my counters just so we can see some stuff going on. And I then get back, I push back some results, very, very simple, status and success. And we've processed this many records, for example. Here's a little handy way that if I know that JSON is coming in over the wire, then I can, basically just say from body and JSON element and work with it as a JSON object, and then start to work out what type of object it is and move it around elsewhere and route it to the process or the module that needs to run it, or the bit of code. So the other thing up the top here we've got is some declarations that indicate what sort of routing paths should be published and should be created under the covers, so that this bit of code, so that when a request comes in, an HTTP request, for example, comes in, then we know where to route it. So other things to keep an eye on, I just reminded myself, other things to keep an eye on is certainly the advent of HTTP3. Keep an eye on that, because it really does provide some amazing performance improvements over the wire by the way that it sets up a session, as well as sending packets and acknowledgements over the wire, and as well as pipelining over the top of it. Now, it's not fully supported everywhere yet through Azure and things, but keep an eye on it. The other one is gRPC, if you're familiar with that. So there's some pretty good compression that gets applied over the wire, over the network. And my performance, my evaluation of that so far has given me 400% performance improvements when I'm making these particular calls. So, okay. So this is my simple little demo. So I'm just going to run this, and I want to show you a couple of things. And as usual, let me see. That's always wonderful. Let me just show you the error. Ambiguous action. Okay. So I've just, this is hot off the press, you see. So basically something in here is a conflict. I've just, oh no. That one I thought would have, two, process transactions. Normally it's if I don't have a post. All right, let's just try this again. Nothing like something unexpected to keep you honest. And all right. Failing this, I'm just going to comment out scenario 3 for the moment. Don't worry, I'll talk about all this code in a moment. All right, so that's all built. Let's try again. And wait for it. Okay. Or executing a request, file fraction, binding. Okay, well, I'm just going to comment, I'm just going to take scenario 3 out because that's what I just made a change with last time. So I'm just, yeah, that'll do. So it's going to take that out. And it's more a discussion point than a piece of code that we're going to go and execute. And let's see now. If these sessions had like, you know, real-time debugging, there we go, we're on, so that the participants could do it. We could do a live share with everyone. And okay, so what I've got here, I'm just going to bring my other window. Here we go. I'm going to bring this one up, and I'm going to bring that one. Okay, so let's try it out. So I haven't done anything unusual. I'm just going to, you know, run this for the moment. And let's just say transaction, because this is our transaction callback. 1, 2, 3, whatever. And, you know, just imagine there's some extra data in there. So it's going to go off. It's going to execute. It'll come out and basically say to us, success. And you can see that it's been executed by Kestrel. That's interesting. So if we're looking at how it's running and what it's doing, it's pretty simple. I've just got, you know, sleeping here for 1,000. And this is kind of where we start from. Now, I can also start to have a look. So I can use some of these things called .NET counters. So maybe I'd like to have a look and see what's going on. And I've got some .NET applications running. And one of those is my demo webhook. And you can see that in debug, and there's some details about that particular process. So what I might do here is come along and I'm going to have a look at some of my custom instrumentation. So I've got this Mick demo webhook, and that Mick demo webhook comes from here. And this is just, I've just put some code in just to show you for demo purposes. You don't normally, you know, have a static in at the top of a controller and all that kind of stuff. But I didn't want to explode this out with 100 different classes. I just wanted to keep it really simple. So I'm creating a new meter called Mick Demo Webhook, and I'm also creating a counter within that meter. So if you go back to you know, Event Viewer and Performance Monitor and things, it's kind of got its logical roots from within there, where we have a whole set of different counters related to CPU, memory, network. This is, you know, an application that may have a bunch of custom counters. So things like you know, things like application insights also produce a very rich diagnostic display. This is just something a little bit different because I want to show you something out of here. And so now we're going to run it. So what this does is it's just monitoring. It's going to monitor that process, and in particular look into that particular counter. So now when I run it, you can start to see that my calls processed there per second, let's say. And if I have several people coming in and you know, having these executing this, then we'd expect that to go up. So that's quite fascinating that we can, you know, have our own counters and various other things and just see what's happening. I don't need to be in the application itself. It's the nature of running .NET that allows me to to do this. So I'm just going to quit this for a moment, and I'm going to go back to that same process, but I can actually now look at some other libraries such as system.runtime. And now when I go and execute my code, you can start to see that there's some details around this and some various other things that they emit out of here as well, such as, what my garbage collector may or may not be doing. Other things such as, well, what my queue length is. So that's really important. And also, maybe what my thread pool queue count is, and thread count. And you can see there that it's either going up or down or things like that. So it's fascinating. So if I start to look at, well, how is my code running? Well, here's what's happening. So I'm just gonna quit that. And really the benefit there was .NET counters. So it's a tool that we can, and I should have the code here. There it is. So the way that we can install that is just simply through .NET tool update, and then go and install the latest .NET counters helper or utility that allows us to go and have a look at this. Obviously, as you're guessing, if I didn't add this stuff in, then when I focused or when I scoped onto my application here, my demo, we wouldn't get anything because we're not actually emitting any custom metrics in this nature. So okay, so that's our first scenario, and we think, all right, well, how big, how many, how much can I put in here, and that sort of stuff. So we now go to. I'm still running, yeah. So I'm just gonna pop back. Yeah, I'm gonna pop back scenario 3, but I don't need to run this anymore. All right, so with scenario 2, what we've decided to do is to introduce some asynchronousness. If that, and this is what we're told to do, okay? And a lot of it works, and there's some considerations that you need to make. So what does the word asynchronous, and this is not necessarily .NET specific, okay? It can happen on other platforms, other languages, and it's always a consideration to make. So asynchronous, when we add the async keyword in, we start to then play around with threads. We have the ability to use and work with background threads. But if we're exposing out an endpoint, for example, is that always a good thing? So if I open up our code here, I've got the same bit of code there where a thread is running this particular piece. We're sleeping for an hour and we're doing, I'm just recording that in our counter. Sorry, we're sleeping for a second, not an hour. Hello. So the other thing too is, and I'm just gonna leave line 46 out for a moment. What we then tend to do is run a series of tasks. So here's some asynchronous tasks, and I've got a routine somewhere that says do work, save to a database, calculate 1 million prime numbers, update some accounts, make a couple of calls, whatever that looks like. But as a developer, I'm just starting at the top, and I'm just working my way down until I've implemented whatever this feature is. So this bit of code kicks off some tasks, and these tasks run. And once we sort of get past this line, task 1 is running, task 2 is running, typically, task 3 is running. And then I can put a line down here that says, well, wait for all my running tasks to successfully finish, or finish, whether it's error state or whether it's completion, and then continue on to the next line. So if we look at this do work routine here, it's also asynchronous. So it's also potentially using another thread. And so here I've got a wait task run. So I've got another Maybe, I can. Oh yeah, I'll leave it. So we're sleeping for 1.5 seconds, and I'm just returning back some data. So it's just to simulate a bit of work. Now this is pretty common. Okay, this sort of stuff that we do, because if you think about, we've either got a weights going on, or we've got have I got it? No, I don't have it here. We've got get a waiter, get result, sort of thing. So as we're calling, whether they're our own libraries or someone else's libraries, there's a lot of NuGet packages that have, do work, and typically they have async as the description on it. I just went and renamed them. Now, is this a good thing? So we just tend to be using threads all the time. But do we have unlimited number of threads? And we're purposely kept, I suppose, away from our threads for a while. We're abstracted away from the underlying threads. Even thread.sleep is a static. It's not referring this. It's I don't have to go to the current thread and say please sleep. It's a shortcut routine for me. So I'm not really in and amongst the actual threads that I'm running. Now there's a routine that we can run, and we can say, well, what are the number of threads that I've got? So what is the maximum number of threads that this process that I'm running in? So the process was this that we went and monitored, wherever that last one was there. So this was our process, for example, that's running. And what's the maximum number of threads? And do we care? Okay. Like, what's, why is the concern here? We'll just go and run it, and surely everything's going to be fine. So remember, the enterprise environment integration doesn't end on your developer's machine. Okay. So there are a maximum number of threads. Yes, I can go and say, please go and set me my max number of threads. And that has different, it impacts things in unexpected ways. So the actual maximum number of threads as calculated by .NET, or by this process as it gets started up, is based on a few different factors around working memory set size, around the number of virtual CPUs that we have access to, and things like that, whether we're running on a workstation or a server. Now, it's not clear sailing. Okay, so let's go back to the running execute the running API now. So this is our callback. Okay, and I'm just going to put in something again. I'll close it off, just being our JSON. So remember that this is running, and we wait a second and a half or so. Now you can see that we've got our top two, standard response there. Yes, we just did 1200. Now on my developer machine, the maximum number of threads that I've got are 32,767. I also have completion port number, which is 1,000, which means basically any threads, if I have threads that are greater than this, my thread count, they will queue and they will pause until we can run them. So basically my completion port, as it's called, which is an unusual name for it, is like a threshold limit. So anything, if I have over 1,000 threads, then the threads that are over 1,000 will be queued up, and until they fall below 1,000, and then they'll start to be executed. Does that really make a difference? And let me show you something. Let me just bring this up for a moment. I've grabbed this solution just a moment ago, and I've gone and deployed it in on Azure. So I've deployed this to a Windows hosted instance of just a simple app service. And let's go and do the same again. So I'm just, doesn't really matter what JSON I send in, just saving myself some typing. And let's go and run this. And this is, if you like, what we would call, production. So that we've deployed it, we've waited our 3 seconds, and we get back some interesting numbers, some very interesting numbers. And that is, we don't have 32,000 threads anymore. We only have 1,023 or 1,024. So anything over 1,000, if we have, and this is our process, right? This is not our, it's not a single user, it's our process. So if our process has over 1,000 threads that are launched and potentially to run, those that are over 1,000 will queue up and wait. So what happens when we've got this sort of code? So even though we say task run, and there's also another thread here, if there's not a thread that's available and waiting, then it's going to queue. And that's what those numbers help us determine. How long can we queue for? Which effectively is waiting, right? It's that thread is blocked, waiting for something to happen, waiting for other threads to complete. And if you think about it, this is an API. So this is a callback. So this is part of a greater project. And it's not, honestly, it's not uncommon for threads to be busy or even hit that number when you're not busy if you've got some very unusual bits of code running around the place. All those asyncs and all those, even when you do an async on an async, for example, like we're doing here, these are all, this runs on this has got a main thread, it runs on a background thread. This will then run, the background thread will launch these will be 3 other threads. And then we come down to here and these will be other threads as well. So, one operation might actually use 10 or 12 threads. Now, is that really warranted if, we've got our main thread that's running it? Surely our main thread might be faster to get through all of this and protect us. So food for thought. All right, so food for thought. And typically when we're exposing out our callback, payment gateway, for example, how long are they going to hang around and wait for us to complete and finish our work? And what should our work be? So we've got, we're running something, we're doing something, maybe saving, persisting, storing in a database. We might be doing some calculations. We might be updating. We might be calling other APIs. We then finish and we return the results back. So all of that, we don't relinquish control until we hit this line here, basically, this end routine. So the payment gateway, what I've seen happen with, things like this, with SaaS services that call you back, if you take too long, they'll just stop the call. They'll just disable that callback. And, you sort of had all these callbacks the day before, the day later you don't, and it takes a little while to figure that out, that they've actually disabled that callback because it was tying up their system and we're taking too long to basically process it. So this sort of leads into what scenario 3 is. So in terms of scenario 3, it's the same code and I've just commented it out. But, how do we do some work? So how do we take this, push it somewhere else, such as, in the back room, and just go off and run it as and when you want to or need to. And if, how do we do that? And so I've just got a little bit of a suggestion here. Is there a way that we might be able to do a queued call, or could we raise an event that this guy responds to? But you can start to see that there's a little bit of plumbing and there's a bit of scaffolding that my developer or I need to do, or the team needs to do, to be able to support this, when really we want to be able to, spend most of our time coding this up to tackle the business problems. Not so much of, how do we manage this asynchronous and synchronous world? So these are some things just to think about as we go forward. The part, I'm just going to finish that, just close down Visual Studio for the moment. And that can disappear too. So the part that I do want to just round out with is there's a fair bit that, we need to consider. How long is too long? What about the threads? Async isn't necessarily wonderful, particularly if you're on a busy or, on an API-based solution. And it's quite easy to have thread starvation, as they call it. And things just get blocked up for 20, 30, 40, 60 seconds, even 120 seconds. It's quite fascinating to see. And so I was once on a solution that had 60 instances in the cloud, in Azure. It had 60 instances. And lo and behold, as soon as we added a new instance, yes, it gave us a brief respite, but nothing substantial. And the throughput of the system was quite poor. And that was because of this particular async pattern that was done, that even objects and entities in collections all got their own threads to go and process a very simple process. So if you had 100 items, each of those items in the collection or array basically had their own thread provisioned to it. And lo and behold, you needed 5 users or 6 users before thread starvation would kick in. So what's our end game? So our end game is that we'd like a great deal of asynchronous processing. And by that, I mean not in the main thread, or not necessarily in the main process. So one of the pieces of technology that I quite like is if you look at Logic Apps, Azure Logic Apps. So here we have, over on the right-hand side, we've got, it's very graphical, it's visual. And over on the right-hand side, we've got, a HTTP request being received. So this is similar to our endpoint being exposed, our callback. I've now got the option of doing some critical processing in this section in here, and then we can send our response back. Thank you for your order. We've received it. We're on our way. So this can be really, really lightweight and really simple stuff that's just enough to be able to acknowledge receipt. It's validated that all the key fields and values are there to be able to perform our function. And then the rest of it can be done after that particular call, that particular response has been sent back. And it's quite powerful, because all that we do is simply move actions and things like that to another place in this particular workflow. I've just set these up. These are scopes, and I've just labeled them and named them. So let me just show you that in real life. And I'm just going to show you. So I've actually got a watch, and this is just on another project that I've been doing. And so it's around health and devices and things like this. So there's a watch that I've got called an MCare digital watch. And basically it's a device that it's an Android-based watch, and it's got a whole bunch of smarts on it. And so what I can do, and this is just a one step before I throw it into the Logic app. So this watch has a whole series of different events, and going through the provider. So when I, for example, do a sync, I've just hit sync on the watch to say please synchronize. Then I've just got some logging data that's come off through here, and here is the payload, and we've got just got a few little bits and pieces, and in particular what the event was, and you can see there my battery on the watch is this. So there's some interesting stuff that we see through here. Now the part that is fascinating is that if I show you the logic app that I've got running, and this is just purely for this demo, so it's not built out nicely yet. We receive the web request coming in, the callback. I just return OK back to the caller pretty quick, and then I'm free to go and do what we want down through here in this main. So I can, for example, I can move that down to the bottom if we want, and start to play around with it. Now this would have been that particular event, which you see down in there, and you can start to see that voltage has come through. So now I can start to play around with this, and this can scale. It's enterprise ready. Someone else is, there's another enterprise environment looking after this, and I've now got the ability to break my tasks up into, critical areas that need to be done versus asynchronous, which is a lot harder to do in code, in this sort of scenario where here's my routine, here's the stuff that I really want to get done, here's the stuff that I need to get done, but not necessarily right there and then. How do we push this to some other place, some other space? Things like microservices and other architectures. New Orleans is another great architecture if you're familiar or haven't seen it. It's brilliant. But, here I've got a graphical environment that's really simple. I view this as a process manager, and basically, oversees the process of whatever the actions are or whatever the operations are that we need to do. So hopefully you can get a little bit of an appreciation of when we start to expose out our callbacks and even APIs for that matter, general purpose APIs. Really good way to have a different lens on it, which is, well, what's critical and what needs to be done, but not necessarily right there and then. So that wraps up me, really. Hope you enjoyed it, and feel free to reach out and contact me. So thank you very much for your time, and hope you enjoyed it.
Thanks, Mick. Let me check to see if we've got, no, we don't have any comments or questions, but you can put those in if you've got them. But at the moment, we don't have any comments or questions. So thank you very much. That was interesting. And I've got, so again, you can reach out to Mick or reach out through Integration Down Under if you need to, if you've got any more questions, things like that. Mick's Twitter handle and everything's in the announcement thing there on Twitter. So that's good. So thank you very much. Let me just.
Thanks, Bill.
Thanks, everyone. And now thanks. So basically, that's a wrap for tonight. And I am not sure whether we're going to have a December one or not, because everybody's really, really busy. If they're anything like at least my schedule looks like in December, everybody's really busy. So I will post on Twitter if we're going to have a December one or not. But thanks everyone for attending, and the recording will be up just as soon as this finishes. So thank you very much.
All right. Thank you, crew.